all, myself Dr. M. Laxmidevi, Associate Professor in the Department of CSCDS at Institute of Aeronautical Engineering. Today's topic is file operations and error handling in C programming language. So in the previous video lecture, we have discussed about the different file operations like how to open a file, how to close a file, and also the associated functions for opening and closing the files. Then we can read from the files by using functions like f, get, c, etc. Then we can also write to the file. We have seen the related functions. You can go through my previous video lectures. So related to these different operations like opening and the closing files, reading from the files and writing to the files. Now in this video lecture, we learn about positioning in the files, how to point or how to locate a particular data in a file. So next one is error handling. So how do we handle errors in C programming language and the associated functions? So before seeing the different file positioning concepts, first we'll see the random and sequential access. So what is random and sequential access? So we can access the data in a file either randomly. So there are two ways in which we can access the data. So first one is random access, another one is sequential access. So these are two different ways or methods you can say for reading and writing data in a file. So these methods, they describe how a data can be accessed and processed within the file. So each one has its own advantages and disadvantages. So coming to the first one, so sequential access. So here the data is processed from the beginning to the end of the file. So we know that file is nothing but a set of, file consists of number of records. So we can access the records in two ways. First one is sequential manner and the other one is random manner. So in sequential manner, if we want to access, for example, suppose a fifth record, so then in order to do that, we have to start from the beginning of the file. So this takes lots of time. So that is what sequential access means. So here we perform the read or write operations in a predefined manner starting from the beginning of the file. So here the operations are performed sequentially. So sequential access is suitable for the task where data is organized. Next one is random access. So in random access, we can access the data at any particular position in the file. So that is what random access means. So we can access the data directly at any location within the file. So we can also perform read or write operations at any particular location or position within the file. So because of this, suppose we want to access the fifth record in a file, then we can directly go to that particular position and we can access the data which is available at that particular position. So here it saves lots of time. So this method is advantageous for the task where we need to access specific data quickly. So such as reading or writing individual records in a database or accessing elements in an array. So these are each set of methods has its own advantages and disadvantages. Now we'll see the pros and cons of sequential access. So as we know that in sequential access, we need to access the data from the beginning of the file. Suppose this is the file. So from the beginning of the file, we need to access, we need to go to each particular record and then access the data, whatever is required. So here it has its, so these are the advantages. So it is simple. It is easy to implement for data which is organized in a linear manner. So it is also efficient in the sense it is efficient for the task which involve processing data in a specific order. So there is some disadvantage with this method. So disadvantage is it is inefficient for the task which require accessing data at arbitrary positions within the storage medium. So we cannot access the data directly at this particular position. We need to start from the beginning of the file. So that is the disadvantage with this sequential access. Next is random access. Random access has its own set of advantages and disadvantages. So here the advantages are it is efficient and it is versatile. So it allows quick access to specific data locations. So we can move to any particular location in the file and access the data at that particular location. So it is suitable for various data storage and retrieval scenarios. So cons are, so these are the disadvantages. So it involves complexity and there are overheads involved in random access. So it is complex. Managing random access, it is more complex than sequential access. Overhead, why? Because it may involve additional bookkeeping to keep track of data locations. So these are the disadvantages of random access. Next, now we'll see what are the file positioning in the files. So in order to perform these operations, so we have different functions. So these are the related functions which we have. So functions to access the files randomly are fseek function, ftel function and rewind function. So with the help of these functions, we can move the file pointer to a particular location and then we can access the data. So first one, the fseek function. So this is the function prototype for fseek function. It takes three arguments. The first one is a file pointer. Next one is offset. Next parameter is an offset. It is of long int type. And the last one is origin. It is of type integer. So return type of this function is integer. So this is used to set the file position indicator for a given stream to a specific location. So with the help of this fseek function, so we can move the file pointer to a particular position in the file. So it takes three arguments: file stream, an offset and origin. So here offset specifies how many bytes to move the file pointer. So offset is nothing but it specifies how many bytes the file pointer has to be moved. So it can be positive or negative. So this offset, its value can be positive or negative. So if it is positive, it means that the file pointer has to be moved in forward direction. The file pointer is moved in forward direction. If it is negative, if this value is negative, it specifies that the file pointer has to be moved in backward direction. Now this is the reference, you can say, from where the file pointer has to be moved. So origin specifies the reference point for the offset. So here origin, it can take three values. So 0, 1, 2. So 0, 1, 2. So 0 means beginning of the file. So file pointer is at the beginning of the file. 1 indicates the current position and 2 indicates the end of the file. So it returns an integer to indicate success or failure. So if it fails, it returns. So if it fails, so it returns a true value if it fails. Else it will return a false value. Next, origin specifies the point where the file pointer needs to be moved. It is specified by the following constants. So here 0 indicates. So we can also write seek set. So seek set means 0, the corresponding value is 0, or you can write seek current. So its value is 1 and seek end, its value is 2. So this indicates 0, this indicates 1 and this indicates 2. So seek set means this function defines the beginning of the file pointer. So with this statement, we can say that the file pointer is at the beginning of the file. So seek current, this defines the current position of the file pointer, and seek end. So this function defines the end of the file pointer. Now let us see the other function, so which is helpful in random access. So next one is ftel function. So return type of this is long int and it takes only one argument, and that is the file pointer. So this function returns the current file position indicator for a given stream. So here the given stream is file as a long int. So it does not take any argument other than the file stream. So next one is rewind function. So this is the prototype for this rewind function. So it takes one argument, that is the file pointer, and it does not return. The return type is void. That means it does not return anything. It does not return a value. So this function is used to move the file position indicator of a given stream back to the beginning of the file. So wherever the file pointer is in the file, so with the help of this function, so we can make the file pointer to point to first position of the file. That means at the beginning of the file. So it takes the file stream as its only argument and it does not return a value. Now let us see for these different functions like fseek function, ftel function, the last one is frewind function. So we'll see each of these functions. We'll see the use of these functions with the help of program. So fseek function, first one we'll see the use of fseek function. So this is a program to illustrate the use of fseek function, how we can use this function. So here this is a program, C program. So we have first one we have declared a file pointer. So fp is the file pointer. Next we are, with the help of this function fopen function, we are trying to open the text file test1. So name of the text file is test1. So we are opening the file in read mode. So this indicates that we are opening the file in read mode, and the fp will hold the address of the starting position of this file. So fp will point to the starting character of this file. So here after this, so the location of this statement will be printed. So location of the current pointer is %d bytes from the start of the file. So since we have opened the file in read mode, so fp will point to the starting position of the file. So this, with the help of this function, we can determine the position of the file pointer. So this, when you execute this program, so this is the output of this line. So location of the current pointer is 0 bytes from the start of the file. So this indicates the current position of the file pointer. Next, when you perform this, when you apply this function, fseek function, so it takes 3 arguments. First one is the file pointer. Next one is the offset, number of bytes by which the file pointer has to be moved, and seek set. So seek set determines. So this indicates that the file pointer is at the beginning of the file. So fseek, this is similar to fseek. So this function states that, so file pointer which is at the beginning of the file has to be moved by 6 bytes. So here number is 6 here. So by 6 bytes we have to move the file pointer. So the output of this corresponding statement is this line. This is the output of this statement. So location of the current pointer is 6 bytes from the start of the file. So we can obtain the current position of the file with the help of this function, ftel function. So it takes only one argument, that is the file pointer. So that is what, after performing these operations, we need to close the file. So after opening the file, we need to open the file, and at the end we need to close the file also. So fclose function, it takes one argument, that is the file pointer. So this is the end of this program. So with the help of this, we can illustrate the use of fseek function and ftel function also. So fseek function, it gives with the help of fseek function, we can move to any particular position in the file. And here this is the file pointer. This one is the number of bytes by which the file pointer has to be moved, and this determines the reference point of the file pointer. Next one is, so we'll see one more program. So in this function also, first, whenever we deal with file handling operations, we need to declare the file pointer first. So pointer variable of file type. So next we need to open the file. So here we are opening the file test1.txt file in read mode. So R specifies here that we are opening the file in read mode. Then after that, we are using fseek function. So it takes 3 arguments, fp, 10 and seek set. So seek set states that the file pointer is at the beginning of the file. So here 10 is given. So this means that the file pointer has to be moved by 10 bytes. File pointer has to be moved by 10 bytes. So after moving by 10 bytes, so we can locate where the file pointer is, at what position in the file pointer is, with the help of ftel function. So the output of this line is 10. Next we are applying rewind function. So when we apply rewind function, so rewind function is used to place the file pointer at the beginning of the file. So rewind function is used to place the file pointer at the beginning of the file, and after that when you're trying to print the current position of the file pointer with the help of ftel function, it will give a value 0 because the file pointer is now at the beginning of the file. Next, after performing these different operations, we need to close the file. So this is a function in order to close the file. So in this way, so we have illustrated the use of fseek function, ftel function and rewind function. Next, coming to the concept of error handling. So there are different errors which may occur. So errors may occur in a file when we are dealing with file related operations. So for example, so these errors may be based upon, so if the file not found or permission is denied. So if there is no file, or if there are hidden files for which we don't have access, and if we are trying to open that function, then you will get this error, permission denied or file not found. So errors when opening a file. So if you are opening a file in read mode and if you're trying to perform write operation, so then you will get errors. So errors when opening the file, then error when reading or writing to a file, error when closing a file, error related to seeking within a file. So file not found or permission denied. So this error can be checked with the help of fopen function. So it may return null if the file doesn't exist or if the program lacks permission to access it. So we can check the return type of this, we can check with the help of this fopen function. So if it returns, so fopen function, if it returns, may return null value. So if it returns null, then we can say that the file doesn't exist or if the program lacks permission to access it. So by checking the return type of this fopen function, so we can handle this error. Next, errors when opening a file. So if fopen fails to open a file, it returns null. So errors when reading or writing to a file. So functions like fread. So these are the different functions which are used to perform read or write operations. So fread, fwrite, fgets, fprintf. These may return an error value. So if they encounter an issue during read or write operations. So next, error when closing a file. So if the file is not closed properly, so it may return EOF if it fails to close a file properly. So next, errors related to seeking within a file. So if we are not able to go to a particular location in the file, then fseek function. So by checking the return type of this fseek function, so we can handle the error. So fseek function can fail. So if it returns a non-zero value. So fseek function can fail if it is unable to set the file position indicator. So these, apart from these functions, so there are so by checking the return type of these functions, so we can tell what type of error it is. So there are some other functions also or methods, so which are used to handle errors when performing file operations. So these are the different functions. So first one is perror function, next one is ferror function, and next feof function, and the last one is strerror function. There are some other functions also. So in this video lecture, we'll discuss about these four functions. Next to perror function. So this is a error handling function. So perror, it states that print error. So P stands for print and error, print an error message. So perror function is used to print an error message to the standard error string along with a description of the error based on the value of the global variable error number. So what is this error number? We'll see later on. So it is defined in stdio.h header file. So in order to use this function, we need to include the header file stdio.h header file. So this is a function prototype. So perror is the name of the function. The return type of this is void. So it does not return anything, but it takes one argument of point. It is a pointer variable of type character. So S is a pointer variable of, S is a character pointer variable. Next, let us see the use of this perror function. So with the help of program. So in this program, so we know that in order to use this, we need to include the stdio.h header file. So apart from this, we have used two other header files, stdlib.h and errno.h. So this is another header file. So first we need to declare a file pointer. Next we need to open the file. So in order to perform any of the operations, first we need to open the file. So we are opening the file named file1.txt. It is a text file, so therefore extension is .txt. So in read mode. So we are opening the file in read mode. So then we need to check the file pointer value. So if the file point, if this function opens successfully, if this file exists and the address of this is assigned to this file pointer, so then it will execute the other statements. Else it will, if this file does not exist, then if fp is equal to null, so this will be true. So this condition will become true. So if the file pointer does not contain some valid address, so therefore this line will be executed. So or this statement will be executed. So p error, so error opening the file. So this function will give the description of the error. So what type of error is occurring in the program. So after that it will exit. So with exit status, exit failure. So exit failure value is defined in the header file stdlib.h. So F close, error opening the file. So when we run this program, you will get this. So this is the output of this program, error opening the file. So this line will be printed as it is. So after that, we know that this p error function, it prints what type of error. So it prints the description of the error message. So no such file or directory exists. So this is the type of the error occurring in the program. Next one is program exit status. So there are two macros, exit success and exit failure, which are available in C language. So these can be passed to exit function to indicate successful or unsuccessful termination of the program. So if the program terminates abruptly, so then we can use these different macros, so which can be passed to exit function. So exit failure is a predefined macro in C which is used to indicate unsuccessful termination of the program. So if the program terminates unsuccessfully or abrupt termination of the program, so then that type of so we can exit the program with the help of this macro exit failure. So it is defined in the header file stdlib.h. Next one is exit success. So it is a predefined macro in C which is used to indicate successful termination of the program. So if the program terminates successfully, we can check the status of this. We can check the status. It is defined in stdlib.h header file. So error number, so errno.h. So this header file, it provides a set of functions and macros for handling error conditions in the programs. So these functions and macros, they are used in conjunction with error number global variable. So here we have a global variable error number. So for each error, so there is a corresponding number. So 1, 2, 3 and so on. So this indicates no such file or directory. So all these values, so with the help of, we can check the value of this. So error number is a global variable. So it has the definition for the different types of errors which occurs in the program. So if you get the messages, so if you get for 1, it is some error, 2 is some error. So description of the error it contains. So which holds the error code of most recent error that which has occurred. So int error number, so this is a global variable which stores the error code of most recent error. So this error number is a variable which stores the error code. So it will contain the code. So with the help of this code, we can identify what type of error is occurring in the program. So we can use it to determine the type of error occurred after a function call. So next, let us see the use of p-error function and this error number variable. So this error number is a global variable which is defined in this header file error number.h. So next, this file we need to include for using printf, and then p-error is also defined in stdio.h header file. This stdlib.h header file, it consists of the values for exit failure and exit success. So this is the program. So here first we have declared a file pointer. Next, in the next line, in order to perform any operation, we need to open the file. So T10, this is the name of the file which we have opened in read mode, and then we have assigned it to a file pointer. If the file pointer contains null, so that means if the file is not opened successfully, then this line will be, these statements will be executed. So if the file is not opened successfully, then if the file does not exist, then these lines will be executed. So in the first line we have the value of this error number. It is a global variable, so it contains some value, integer value. It can be either 1, 2, 3 and so on. So corresponding to each integer value, there is some error indicated. So next, in the next line, we have used p-error function. So this p-error function, it will give the description of the error Next line, we have used the exit function with exit failure status. So if when we run this program, so if this file does not exist, then this is the output of this program. So otherwise, if the file exists, then it will execute these statements. Then we can see here, so t1.0, if it does not exist, then the output of this line is 2. So corresponding to error number, so this is a global variable. So we are getting a value of 2 in this case. So because fp is equal to null, that means the type of error which is occurring here is the file does not exist. So corresponding value is 2 in the header file. So this 2 value is, so error number value is 2. So that value is printed here. So in the next line, p-error function will give the description of the error message. So this is what the error message is. That means no such file or directory exists. So in this way, corresponding to 2, the description of the error message is no such file or directory. So in this way, we can find out the different types of errors with the help of this error number variable which is defined in this header file. So next one is strError function. So its function is also same as p-error only. So this will also give the description of the error message, but the prototype is different here. We can see that this is a prototype of this function. So strError function is also used to show the error description. So this returns a pointer to textual representation of the current error number value. So this is a function prototype. So you can see here, so it takes one argument, that is integer value. So error number is the integer, it takes integer argument, and the return type is character pointer. So here error number is the error number. So error number is defined in the header file IARE header file. Next, we need to include this header file. So when we are using the macros with exits to check the status of this exit function, so we can use exit failure and exit success macros. So these macros are defined in the header file stdlib.h. So next, so first we need to open the file. So the file pointer is fp. So when we are opening the file, so t10 in read mode. So if fp is equal to null, that means if the file does not exist, so these statements will be executed. So this value will be printed. So error number value, the corresponding value is 2, and after that we are using the strError or. So strError, so it takes one argument. So argument is error number. So the output of this line is this one, no such file or directory. So this will give a error message. So it will give description of the error. So no such file or directory exists. Next, p-error function also does the same. So it will also give the description of the error. So this is the output of this line, no such file or directory. So next, after that, it will exit the program. Next, ferror function. This is used to check if an error indicator is set for a file string or not. So if it is false, so we can say that if there is no error. So if this error function does not return, if it becomes false, then there is no error. So if there is any error, then it will return true value. That means a non-zero value. So it is used after performing operations on a file, such as reading or writing, to determine if any error occurred during those operations. So this is a function which is defined in the header file stdio.h. Now this is the function prototype. So the return type of this is integer. So it will return either true or false. So it returns true if there is an error. It returns false if there is no error. So input is one argument. So it takes one argument, that is file pointer. Now let us see the use of this ferror function with the help of program. So file is a file pointer. So we are opening a file out.txt in write mode. So if the file does not exist, if the file pointer value is null, then these statements will be executed. Else, now we are opening a file in write mode. So if the file does not exist, that file will be created. So these statements will be executed. So if printf, so printf is a function, so which gives, so we know that printf is a function, so which will print the value on the screen, whereas fprintf is a function. With the help of this, we can print the values to the file. So if with the help of fprintf function, so it takes two arguments. So these are, first one is the file pointer and next one is the string which is to be printed to the file. So the value of this, if it is less than 0, then this error will occur. So if error of file, if this statement becomes true, then error writing to a file. So if this data is not returned to this file, then this condition will become true, and then PError will display the error message. So else we will get the output as this one: data is returned successfully. Data is returned to the file successfully. So when we run the program, so we have opened the file out.txt in write mode. So if we can check the contents of this file out.txt, so it will be hello world. So whatever we are using here, so those contents will be printed to the file. These contents will be copied to the file. So that's why, so we'll get this as the output: data is returned data returned to the file successfully. So after that, we need to use this function to close the file. In this way, we can use the ferror function. Next one is feof function. So feof function is used, it is contained in the header file stdio.h. So it is used to check whether the end of the file indicator has been set for a given file stream. So that means end of the file character has been reached or not. So if it reaches, it returns a non-zero positive value. If end of the file indicator is set, otherwise it returns 0, that means false, indicating that the end of the file is not yet reached. So this is a function prototype, feof function. It return type is integer and it takes one argument, that is the file pointer. So it returns 0 if it becomes, so it returns 0, indicating that end of the file is not yet reached. So if it returns true if the end of the file has been reached. Now let us see the use of this function. So this is a program. So here we have declared a file pointer fp and we are opening a file test1.txt in read mode. And then if the file does not exist, so in order to handle that, we use these statements. Next, if the file exists, otherwise these statements will be executed. So while one means, so in the loop we have used a while loop. While one indicates that this is a infinite loop it is. So we are in this loop, we have these set of statements. So it reads data from the file character by character. So that is done with the help of getC function. So getC function is used to read the character from the file which is pointed by fp. So if we are checking the condition, if end of the file character has been reached or not. So if it becomes true, if this condition becomes true, then we have written, it will enter, these lines will be executed. So that means break, that means it will come out of this loop. So after that, else the character is printed on the screen. So printf statement, with the help of printf statement, we can print the character on the screen. So this is the output of this program. So test1.txt, it contains, these are the contents of this file. Hello, how are you? So those contents will be printed on the screen. Hello, how are you? Program to get the count of number of lines from the file. So these are the contents. So this it reads character by character from this file and prints it on the screen. So in this way, so we have seen different functions in order to locate or in order to go to a particular position in the file and access the data at that particular position. We have different functions like fseek function, then ftell function, then after that we have rewind function. So this rewind function will move the file pointer to the beginning of the file. ftell function, it gives at what position the file pointer is, and fseek function, with the help of this fseek function we can move to a particular position in the file by with the help of the number of bytes which are specified in this fseek function. Next, apart from that, we have used some of the we have seen some of the error handling functions for in file operations. So these are perror function, feof function, etc. So these are some of the functions which we have discussed in this video lecture. So in the next video lecture, we'll discuss some more concepts of C programming. Until then, thank you.
Like, share and subscribe. Hit the bell icon for more updates.